Foundations of Amateur Radio. When you join a new community, you learn very quickly that each community has its own language. A word in one community has a different or extra meaning in another. For example, the word snowflake in one community might refer to a phenomenon related to water and freezing. In another community, it refers to a person who is sensitive, easily hurt and offended. If you mix the two meanings, all manner of misunderstanding ensues. In amateur radio, one of those words is the word gain. This word is used in many different aspects of our hobby, but today I'm going to focus on one specific use of it, in relation to antennas, antenna gain. This mythical property of an antenna is often used as a way to distinguish two different antennas, and in advertising terms, bigger is better, more gain, more better. I'll skip over the marketing shenanigans related to artificially making the number larger by comparing apples and pears, or dBi and dBd, and move on to how gain comes about. Let's look at something completely different. A light bulb. One of those tiny ones you find in a torch, or on the front of your bike, or even one in your car. In essence, we have a gadget that emits energy in the form of light and heat when electricity is applied. The specifics aren't important, but let's just say we're going to ignore more voltage and more amps for the moment. If you have a bare light bulb, light and heat radiates in almost all directions. You can't see any light where the fitting is, but everywhere else is a pretty uniform pattern. For the moment, let's ignore the fitting. If you were to get a piece of black cardboard and drill a hole and put a light through it, you've essentially removed half of the light. Below the cardboard, there is no light. Above the cardboard is the same amount of light as before. Half the light is being stopped by the cardboard, and it's essentially lost. Technically, it's getting absorbed and the cardboard is getting a little warmer, but let's not confuse the issue for the moment. If you were to make the cardboard reflective, say some foil, white, a mirror, whatever, the light that was hitting the cardboard would be reflected away from the cardboard, and you'd experience that as the light getting brighter. Notice, though, it's still dark below the cardboard. In essence, you've just increased the gain of your light bulb, and it didn't cost you any more electricity to make that happen. Antennas work in much the same way. There are a few more wrinkles. A light bulb is working with light and heat frequencies. Wavelengths are between 100 micrometers and 100 nanometers, where the antennas we use in amateur radio typically look at 100 meter to 23 centimeter. So the material aspects of our mirror equivalent are different, but have a similar idea. One thing that's fundamentally different between a light bulb and an antenna in our hobby is that a light bulb is generally only transmitting, where we tend to both transmit and receive with an antenna. Remember when I skipped over the bit of the light bulb below the cardboard being dark? That's the antenna equivalent to not hearing something, which means that you're better able to hear the signal in the direction you're pointing. The same is true for the bit about the light bulb fitting and no light below it. In antenna terms, this phenomenon relates to the front-to-back ratio. Imagine turning your antenna 180 degrees. Pointing one way, the signal is of this strength. Pointing the other way, it's that strength. Divide the two. If they're the same, the front-to-back ratio is 1. Otherwise, they express the directivity of the antenna, another number you can use to market your antenna to an unsuspecting amateur. So far, we've only looked at using a single reflector for our light bulb. But if you were to use a torch, you'd get even more directivity and more gain. The same amount of energy pointing at a smaller area. The ultimate expression of this is a laser beam, which is essentially a single focused beam of light with no light anywhere other than where it's pointing. Antennas do the same thing, using different methods, but the most common one is to add more bits of metal to focus the radio energy. A light bulb emits energy in all directions, and an antenna does too. Even if you were to make an antenna made of elements all aligned in the same direction, the pattern is still mostly round. That is, it's like a cone of radio, regardless of the shape of the antenna. Yes, there are ways of making antennas that don't make round cones, but that's a conversation for another day. But think about this. What would happen if you were to squash an antenna pattern and then focus it? I'm Onno, Victor Kilo 6, Foxtrot, Lima, Alpha Bravo.